Hello everyone, welcome back to our channel. And in the other video, I taught you how we can graph motion. So that is distance versus time graph. Now we're going to um, explore displacement versus time graph. But put in mind that displacement is not the same as distance. So as displacement is a vector quantity and it follows vector operation. So you may be shocked if there is a difference between the answers, but we are going to help you to explain that. So displacement is always plotted along the y-axis and time is always plotted in the x-axis. So I have shown you my graphing tool and it's down here. Then we can pull that up. So we have GeoGebra. So for example, I have pick a starting position, all right, because what matters most in the displacement is the initial and final position of the object. So we put the origin at 0, 0 and 0 to be our starting point. So you can see here that the point is being shown and it's in the x and y intersect, and then it has a coordinate of 0 and 0. So let's say for example we move from point A to another point on the graph or on the Cartesian coordinate plane and we move to point D. Alright, so that's within 2 seconds. Okay, so time is passing by and we didn't stop in point B, but we move somewhere here. Alright, there we go. And then you will see that this is no longer a straight line because there is a change in uh, position. So meaning to say from point B you go back, okay, you go back a little backwards, okay. So but nonetheless you did not stop, so meaning to say you have a certain amount of velocity. So we can actually connect uh, the points using line segment, and as you can see the line segments are getting plotted, and we will see that the distance of line segment G from uh, B is 1.99, and so as with segment F, which is 2.83. Okay, so and then we did not stop in point C, we moved somewhere up or forward, all right, and we move to point D. Then we can actually graph that. So we all know that every motion has its velocity. Then let's say we go back a little bit here, then somewhere here, then finally here. All right, now what is the displacement? Okay, so that's your first question, your displacement from point A to point G. Okay, all right. So as I've mentioned, it has something to do with the initial and final position. So we get that initial to final position. That's it. Okay, this is our displacement, and it says here that um, that's 13.4. Okay, so what's 13.4? It's the length of the path of the displacement from point A, and that has to be a straight line. Okay, so I can actually remove this other segment so that we can highlight. Uh-huh. Okay. Alright, so now we will find the average velocity, and the average velocity can be uh, found, okay, using the total displacement covered over time. Okay, so we open the paint, paint. So average velocity, we have displacement, which is a vector quantity, so I put an arrow there, over time. Alright, so or delta D, okay, all over delta T. Okay, and when we say delta D, that has something to do with the initial and final position. So with respect to the graph, that has something to do with y sub 2 minus y sub 1, wherein y sub 2 is the initial position, and then y sub 2 is the final position rather, and y sub 2 is the initial position. Then t sub 2 is the final time, and t sub 1 is the initial time. Alright, so we compute for that, and the final coordinate, x coordinate, is actually, as in the graph, you will see that it is in 11 and 7. Okay, so those two are the only thing that matters, okay, in our calculation. So we have 11 and 0. I'm gonna write it here. 11 minus 0, so that's 11 meters, and 0 meters all over 7 seconds, I mean, minus 0 seconds. So that's 11 over 7, okay, meter per second. So you can get your calculator and you will get the average velocity as 1.5714 meters per second. So that is, we can write V average for average velocity, okay, is equivalent to 11 over 7 meter per second, or 1.57 meters per second. So that's how we get the average velocity based on the graph.